This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 2, Lesson 2, Envelope Conduction Loads. Every opaque surface of a building, the walls, the roof, the floor, a slab on grade, leaks heat by conduction whenever inside and outside differ in temperature. The method is always the same 3 steps. Stack the layer resistances into a total, invert that total into a U factor, then multiply U by area and temperature difference to get the load. We'll build the resistance network, pull the R values from the handbook tables, and work one multi-layer wall end to end. Concept 1. Resistance first, load second. A conduction load is heat pushed through the wall by the indoor-outdoor temperature difference, and you build it in 3 moves. Add the layer resistances in series to get the total. Invert the total to get the U factor. Then multiply U by area and temperature difference for the load. The series resistance building blocks come straight from the heat transfer chapter, TFS Week 3, so we use them, we don't re-derive them. Concept 2. The resistance network and the per area basis. Read the wall as resistors in series. A surface film, each material layer, the other surface film. Here's the subtlety that trips people. The heat transfer chapter writes the total resistance forms, length over Ka, 1 over Ha, with area in the denominator. The handbook R value tables print those same resistances per unit area, length over K, 1 over H. So sum the per area values, invert to get U per square foot, and let the area re-enter exactly once, at Q equals UA delta T. Concept 3. Turning U into a load. Once you have the U factor, the load is that U factor carried across a temperature difference. The handbook prints the UA delta T relation for an interior surface facing an adjacent unconditioned space. Q equals UA times the adjacent temperature minus the inside temperature. The exterior envelope is identical in structure. Build U from the network, then drive it with the design indoor minus outdoor difference. For a heating load, that's the full winter swing across the wall. Concept 4. The slab and earth contact path. A floor slab on the ground just adds one more resistor to the same series stack. A slice of soil, its resistance equal to the soil path thickness over the soil's apparent conductivity. Add the slab and the inside film, invert for U, and load it the usual way. The handbook gives apparent soil conductivity by soil type as lookup data, but no below grade or slab edge loss method. So treat the earth path as the ordinary length over K resistor. Setup. 100 square foot wood frame wall. Outside wind film, 1/2-inch plywood, a 3.5-inch mineral fiber bat, 1/2-inch gypsum, inside still air film. 70 inside, 0 outside, a 70-degree swing. Each layer resistance comes straight off the handbook tables on a per square foot basis. No area baked in yet. Area enters only at the last step. Solve. Sum the 5-layer resistances, 14.92. U is 1 over that, about 0.067. The load is U times area times delta T, 469. And notice the bat alone is 13 of the 1492, about 87% of the resistance. The films and boards barely register. The insulation is the wall. Traps. 5 ways this bites. 1. 2 resistance bases. The tables are per square foot, so sum, invert, and bring area in once, never twice. 2. Count both films, inside and outside. Drop one, and you overstate the load. 3. Material K is per inch, so resistance is thickness in inches over K, or 1 over C for a listed thickness. 4. Use the printed UA delta T form. Build U from the network and the tables. 5. A plain stack is pure series. Parallel paths like studs beside the cavity need area weighting. Quick recall. Build the per square foot resistance sum, invert to a U factor, load with UA delta T. The printed load form is the interior surface UA delta T. Count both surface films. Material resistance is length over K or 1 over C. A slab just adds a soil resistor, and soil conductivity is data only. Golden rule. Keep R per square foot, invert to U, and multiply by area exactly once. Next up, Lesson 3, Fenestration and Solar Gain. A window keeps the same conduction term you just built. then adds 2 more, a solar gain term through the glass and an air leakage term. 3 loads through 1 opening, area weighted across glazing and frame. Everything's at PEPrepEngine.com. Cheat sheet, work solution, and a quiz attached here. If the course helps, subscribe.
The full study guide with every equation and common exam trap is free at PEPrepEngine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.